Hey guys, it's Miss Ava and I'm here with Calculina, and in this video we are going to go over how to find the LCM and GCF, and I'm going to show you how to find the LCM and GCF of small, simple, easy numbers and then all the way up to like complicated algebraic expressions. So before we get started though, I do have the PDF of the worksheets that we're about to go through. And so the link for that is in the description. If you want to download it now, you can kind of follow along, or you can download it after and try this entire session again, the lesson, which would be my recommendation personally, because I think that that is a really good way of learning. Okay, so let's get started. First, just some quick notes. The LCM and GCF is about comparing. So it's not like an operation. You're not adding anything or two things. You're just comparing, which means in order to compare, you need at least two numbers or two sets of factors so you can compare the two. Then when it comes to LCM, that stands for the least common multiple, and then GCF stands for the greatest common factor. So if you think about multiples, multiples are like multiplying. So what do you think, Calculina? Can you give me some multiples of 20?
Yeah, sure. Uh,
Like you can go ahead and get started with 20 times 1. What's that?
that's just 20.
Okay, good. And then you would do 20 times 2.
40,
Good. Keep going.
60, and then 80, and 100.
Okay, good. So that's probably good. We'll stop right here. Then now let's look at multiples of 30. Let's go ahead and fill that out right now too. Go for it.
Okay, we could say 30, 60, 90, 120.
Okay, that's good. Yes, awesome. So we can see that multiples keep going. We could just come up with more and more multiples. All right, let's see about factors. Tell me some factors of 20.
Okay, are those just like the numbers that go into 20?
Yes, exactly.
Okay, so like, 5?
Yes, 5 is a factor, but why don't we do this? Why don't we start with the smallest one? So how about 1? Does 1 go into 20?
Yes,
Okay, cool. So we'll start with 1. Then what about 2?
yes,
Okay, then what about 3?
no,
Okay, 4,
yes,
5.
yes.
Okay, and see when you get to this point where you have the two numbers that you can multiply together and it will give you the 20, then that's when you can just kind of start going backwards. So we did the 4 times 5 is 20. Now 2 times what is going to give you 20?
10.
Okay, good. And then what do I put for the 1? 1 times what?
That would be just 20.
Okay, awesome. So let's do the same thing for the 30. Go for it.
Okay, so then you're going to start with a 1, and then you could put 2, and then you could do 3. You can't do 4. You can do 5.
Good.
Then you could do 6.
Yes, and then do you see how we're at that spot now?
Oh, yeah.
Okay, cool. So what's next?
Then that would be 10, and then 15, and then 30.
Awesome. Okay, so now if we're trying to look for the LCM here, the least common multiple means it's going to be the smallest one that's in both of them. What do you think? What's the answer then?
So would it just be 60?
Yes, that is correct. 60 is the smallest number that shows up in both lists. So that's the LCM. Okay, now let's look at the GCF. So GCF, greatest common factor. That means we are looking at the biggest number in both sets of factors.
Okay. Uh, is it the 5?
No, it's not the 5 because there's a bigger one.
Oh, okay. Oh, it's 10.
Yes, exactly. Yeah. There are multiple factors that they have in common. There's the 1, 2, 5, but the biggest one is 10. So that's the greatest common factor. So another thing to note here about the two lists is you can see that the one for the factors, that one is a finite list, whereas for the multiples, it is an infinite list. So now just to kind of give you an overview, this is what we'll be covering today. First, we're going to look at the LCM and GCF of small numbers, which we've kind of already done. This is very similar to the two problems we just did up here with the 20 and the 30. So it's the same kind of process. And then we're going to look at the LCM and GCF of bigger numbers and how to handle that situation. Then we're going to look at LCM and GCF of variable factors, and then binomial factors, and then finally, there's just going to be some mixed problems. All right, so next one, we're looking at small numbers. Okay, so small numbers. Here's the first example here, the 12 and the 18. When I say small numbers, I just mean numbers that are like, it's something that if you want to try and figure it out in your head, you probably can do that, or you can just do it by making the list like we were doing. So that's, either of those methods work, but you don't have to do like the more complicated methods that I'm going to be showing you after this. So for the 12 and the 18, let's try and do it the short kind of way, like the way that we did the last two. What do you think the LCM might be here?
Um, uh, so should I just write out like multiples of 12 and 18?
You can do that, or I mean, if it's not something you can think off the top of your head, then definitely that's something you can do. But what about if we just started with the bigger number? Like, tell me the multiples of 18.
Okay, so that would be like 18.
Yes. Does 18 work? Does 12 go into 18?
No?
Okay, so then the next one, 18 times 2, what's that?
That's 36.
Good. And does 12 go into 36?
Yes,
Okay, awesome. So then what does that mean?
that our LCM is 36.
Yes, exactly. Okay, and then for the GCF, what do you think that might be?
Um, is it, I keep wanting to say 12, but I know it's not 12. Is it 6?
Yes, it is 6. 6 is the biggest number that can go into both of these. Okay, awesome. Then what about 5 and 15? What might the LCM be here?
Um, the LCM, it's not 5, right?
Nope, because can 15 go into 5?
Oh, no. Um, okay. Is it 15?
Yes, it is 15. 15 is the smallest number that both of these can go into. Those two things can be very confusing, You just have to kind of keep that straight, which one means what. Okay, what about the GCF here?
Um, the GCF, the biggest number that goes into both of them.
Yes.
Okay. So this would be 5.
Yes, exactly. So it is possible for your LCM or your GCF to be one of the numbers, right? That's definitely possible. And whenever that is the case, the LCM can only be the biggest number and the GCF can only be the smallest number. So that's kind of how that would work. Okay, then for the last one with the 2 and the 3, what do we have for the LCM?
The LCM, it could be like 6.
Yes, exactly. This one's 6. And so that means that you can just multiply the two numbers, provided that that's going to give you the lowest number that is the common multiple. Okay, and what do you think the GCF would be then?
Um, Nothing. Like you just put a 0?
No, you can't put a 0. You can always put a 1. When there's nothing, or it seems like there's nothing, it's just a 1. Yeah?
Oh, okay.
Awesome. So let's keep going. So now we're going to look at how to find the LCM and GCF of bigger numbers. I don't mean numbers like these guys necessarily, because these are not huge. There's still something you can actually figure out without having to do this big long process that I'll be showing you here. But like, let's try that. What would the LCM and GCF be here? What do you think, Calculina? If we tried it with the same methods that we were trying with the other numbers, the smaller numbers.
So then for the LCM, you would just basically just do multiples of 150, right?
Yes,
Okay, so 150 wouldn't work, and then 300 would work.
that's correct, 300. And then what about for the GCF?
The GCF, it's not going to be 100. Is it 50?
Yes, it is just 50. Very nice. Okay, so do you see what I mean? It was kind of easy to figure those out. You could even do it as if it was a 10 and 15 and then just add zeros to your answers. So yeah, that's not exactly what I mean by the bigger numbers. What I mean is when it's something that is complicated looking like this. This is something that's not going to be easy to just solve. So what you want to do when you have numbers that are relatively big, and chances are if you just try to figure out what all the, multiples and the factors might be, then you will probably come up with a pretty long list. So for these kind of problems, this is what you want to do. First thing, you're going to do the prime factorization of both numbers. So that means I'm going to do the 945, and we have to break it up into prime factors. So we can think of two numbers that multiply to give us 945. So maybe you can try 9 times 105. That should work. Are either of these prime?
No?
Okay, so let's break them down. So 9 could turn into a 3 and a 3. Is this prime?
Yes.
Okay, cool. So we circle those. And then we need two numbers to multiply it and give us 105. So how about like 5 and 21? Is 5 a prime?
Yes.
Awesome. And 21?
No.
Okay, cool. So let me break that down a bit more. What am I going to get here?
You're going to get 7 times 3?
Awesome. Yes, 7 and 3. And are they both prime?
Yes.
Perfect. Okay, so the prime factorization for 945 turns out to be 3 to the third times 5 to the 1 power times 7. And I got these from all of these guys right here. So there's 3 threes, so that's 3 to the third, 5 to the 1, and 7 to the 1. Then let's do the other one as well. 675, we break this one down. And two numbers that multiply to give us 675, well, there is 25 and 27. And I know that because I'm thinking of quarters. How many quarters can go into $6.75? That's going to be 27 quarters. So that's how I was thinking of that. Then the 25 is not a prime, so we have to keep breaking that down. That'll give us a 5 times 5, and both of these are prime, so we circle those. And then how about the 27? What can that be broken into?
You could do 9 times 3.
Good. Awesome. And then I'll break the 9 down a bit more, but the 3 is a prime, and then this becomes 3 and 3. Okay, so what's the prime factorization for 675?
That's going to be 3 to the third power
Good.
times 5 to the second power.
Yes, awesome. Then once you have those prime factors done, you're going to rewrite the numbers as those prime factors. So let me do that first. That's like 3 to the third times 5 to the 1 times 7. And that's like one group. You're just going to think of that as one group. And then the other one is 3 to the third times 5 to the 2. So once again, these are two different groups of numbers. What you're going to do for the LCM is you're going to write down every base that shows up, regardless of whether it shows up in this group or in this group. And when I say base, what I'm referring to are these guys. These are the bases right here, and the little numbers are the exponent. Okay, so first thing, we write down every base that shows up regardless of which set of numbers it's from. So that means I'm going to write down a 3, I'm going to write down a 5, and I'm going to write down a 7. And then the next thing is that you compare each one of these. So I'm going to look at the 3's and just look at their exponents, and I choose the exponent that is greater. In this case, they're both the same, so we're just going to have a 3. And then for the 5, I do the same thing. I'm going to compare those two. And since the 2 is bigger, we use the 2. And then for the 7, there's only one 7. And so that's the one exponent that I have to use right there. So that, when we multiply that out, that's actually going to give us the LCM, which actually ends up being 4,725. Then for the GCF, what you do in this case is that this time you're going to only write down the bases that are in both. So only the popular bases get invited to this party. So that would be the 3 and the 5. Those are the only ones that are in both. And then now when you go through and you're comparing, you're going to choose the smaller exponent this time. So once again, with the 3's, they're both 3's, so we just use the 3 as the exponent. And for the 5, which exponent will I write down?
You're going to use the 1.
Okay, awesome. And then once you have that, then you multiply that out, and then that will give you the GCF, which in this case is going to be 135. All right, so let's go through that process again and just fill in these blanks right here. So this part, I'm just explaining what that format is and how we had the base and then the exponent. And so that's kind of what you're looking at within each group, and you kind of put everything into prime factors like that. And then let's try out some of these fill in the blanks here. Step 1, rewrite the numbers as what?
Prime factors?
Yes, you want to do the prime factorization of those numbers. And then for the LCM, what did we do? Write every base that what?
You write every base that shows up, like in either of the two groups.
Yes, you write down every base that shows up. Shows up in either set of numbers. So every base that shows up in either set of numbers, and then compare the exponent of each base and use the blank one. Which one do we use for the LCM?
You use the bigger exponent for the LCM, right?
Yes, that is correct, the bigger one. And then we just multiplied that out. And then what about for the GCF? This says write every base that what? Which base did we use for the GCF?
You wrote down, oh, these were like the popular bases, right? That means that they were in both.
Yes, exactly. So we write down every base that shows up in both set of numbers. And then we compare the exponent of each base and use the blank one. Which ones do we use this time?
You use the smaller exponents.
Awesome. And then we just multiply, and then that is our answer. That's our GCF. Okay, next up, we're going to do the same thing, except this is with variable factors. So you can see right here, instead of having the prime numbers as the bases, this time the bases are just variables. But you do this the exact same way. So which bases should I write down for the LCM then?
So you're gonna write down every base that shows up.
Yes, because every base is invited to this party. So what do you want me to write down?
Write an A, a B, a C, and a D.
Perfect. Okay, and then now we go back and we start comparing. This is a to the third, this is a to the fourth. Which one do I go with?
You go with the fourth.
That's correct. To the fourth. How about for the b? What's the exponent going to be for the b?
Do you just use the 3?
Yes, you just use the 3 because there's no other b to compare it to. Then what about for c?
This one you will go with the 7.
Perfect. Okay, so that's going to be c to the 7, and then d.
Just nothing?
Yes, that's correct. Or I could put a 1. It's the same thing, right? When you don't see something there, the exponent is just 1. Okay, and then tell me for the GCF, which bases should I write down this time?
This time you can write down an A and a C.
Perfect. Okay, and then what will the exponents be for each of those?
Okay, for the A, you're gonna choose the 3.
Yes, exactly, because you use the smaller one. And then for the C?
C, you're gonna go with 2.
Yes, that is correct. Awesome. Okay, very nicely done. Let's quickly just do this problem as well. So LCM, which bases do I write down?
You can write down an A, a B, a C, and a D.
Yes, awesome. Look at you, you're getting faster. Okay, and then what exponents?
So for the A, you can use the 3.
Awesome. And for B?
B is gonna be the 2. Oh no, it's the 5th, the 5 one.
Yes, exactly. It's the 5. Okay, and then the C?
C is the 3rd, and then the D is just gonna be to the 2 power.
Excellent. Okay, and then tell me about the GCF. Which bases should I write down for that?
You can write down an A and
Wait, an A. But this group doesn't have an A.
oh, okay. So it has to be in everything.
Yes.
Okay. Well, then uh there aren't any.
Yes. They don't have like each one of these is missing at least one thing, right? So there's nothing that's in all of them. So when that happens, when you have that sort of situation, this is another one of those where you just say that the GCF is 1.
Oh, okay.
Okay, so then let's keep going. This is the last strategy that I'm going to show you guys. This one is for binomial factors. So find the LCM and GCF of these. These are what binomial factors look like right here. This and this. So all of these are bases. They're actually their own bases. So even though they look more complicated, I want you to think of them as just like the same way that we were looking at the last set of problems where it was like a to the 5, b, c, so on. These are just like that. Is that cool?
Maybe.
Okay, well, let's go ahead and try it out. So tell me what bases I should write for the LCM.
You can write an X
Uh-huh.
and a 3.
Oh, are you telling me like this X and then this 3?
Yeah.
Okay, so that's what I mean. Like you want to look at this entire thing as its own base. So, like what if I had a smiley face to the third power, and then a sad face to the second power, and then a triangle. And then another one I had like a smiley face to the fifth power, and then I don't know, a star and a square to the third power. Like here, what bases could I use for the LCM? What bases could I use for the GCF?
Like for the LCM, wouldn't it just be like smiley face and then sad face and triangle and then the star and the square?
Yes, exactly. So it's the same kind of concept. You're just doing that over here. What I want you to do is think of each one of these as like this.
Oh, okay. I think I see what you mean.
Okay, cool. So then let's try it. Which bases can I write for the LCM here?
Um, you can write like x plus 3.
Perfect.
Okay, then x minus 1
Yes.
and a plus b.
Awesome.
And then, is that it?
No, that's not it because see, this one is not the same as this. Those are two different, even though they look very similar, those are different bases.
Oh, okay. Well then, um, x plus 1.
Yes.
And then, is this one different too?
Yes.
Okay. So then 2a plus b.
Perfect. Okay, and then what exponent should I use?
Um, for the x plus 3, you can say the 2.
Yes, exactly.
And then for the x minus 1 is also a 2. And then x plus 1 is a 3, but the others don't have an exponent.
Awesome. And then what about for the GCF?
The GCF, uh, you're going to write down the base x plus 3.
Good. Anything else?
I want to say no.
That's correct, because none of these are common. Even though they look similar, they have to be exact. Okay, so then tell me what exponent I use for the x plus 3.
Um, just nothing.
Yes, or just a 1. Very nice. Okay, so hopefully you kind of have a better idea about what I mean with these. I'm going to leave at least this problem for you guys to try out, and then let's skip ahead for a bit. So far what we did was we went over a process for finding the LCM and GCF of small numbers, which was things like 5 and 10. And then we went over a process for finding the LCM and GCF of bigger numbers, which was like 795 and so on, just big numbers with a lot of factors. And then we went over a process for finding the LCM and GCF of just variable factors and bases. So this was like the a to the third, b to the, whatever, second, those kind of problems. And then we went over how to find the LCM and GCF of binomial factors. So these were the ones that look like x plus 2 squared and so on. So based on these, this is the last thing that we're going to look at in this lesson. And you guys at home, you can actually do the problems here and you can find the LCM and GCF. I have that in the answer key for this whole worksheet. So if you download it, you'll be able to see the answers as well. But what Calculina and I are going to do right now is just talk about which of these methods would you use for each of these problems. So these 4 methods, tell me which of these you would use for this problem.
Um, like the fourth one.
Yes, it definitely has binomial factors.
And then that's it.
Well, not quite, because see this x squared right here, that's like just a variable factor. So we would also use that method, right?
Oh, okay, yeah.
Okay, and then how about this one for number 2?
For this one, uh, you can use like the small numbers method.
Um, well, you can. I guess that's up to you, but they have a large number of factors and definitely complicated multiples. So personally, I would actually use the the bigger number method for this one.
Oh, okay. Yeah, that makes sense. I think I would do that too.
Okay. All right. Well, then I will just put the 2 in there. And then anything else?
Yeah, isn't it also the variable factors?
Yes, it is. So I'll put the 3 in there. Awesome. Okay. And how about for number 3? Which strategies would you use here?
For this one I would probably do with a small number method, right?
Yes, that's what I would do as well. So I'm going to put that. Anything else?
Yes, it also has the variable factors,
Good.
uh, and the binomials too.
Yes, exactly. It does have that one too. So there we go. And then here's the last one, number 4. So these are the 3 numbers that we have right here, or the 3 sets of numbers. And then what do you think here?
Well, all of those numbers look pretty big, so probably the big numbers method.
Good.
And then also the variables, um, and then the binomial one as well, because of this one and this one too.
Yes, exactly. Awesome. So that is basically our overview of LCM and GCF. And I hope you guys found this helpful. Please like and subscribe and let me know how you did with the practice problems in the comments.